Welcome back to our channel. Today we are tracking a critical topic, which is a single point of failure, and how to solve it or how to avoid a single point of failure in system design interview, because it's a pretty important topic and it's a huge red flag if you build your system in your interview and it has a lot of single point of failures. This is a big red flag. So we have to give a lot of attention of how to avoid any single point of failure in our systems. So by the end of this video, you will know how to identify a single point of failures and strategies to minimize or eliminate them, ensuring your system remains highly available and scalable. So, what is a single point of failure? A single point of failure is any component in your system whose failure can cause the entire system to stop working. Like imagine bridge that's the only route between two cities. If it collapses, both cities cut off are cut off basically. So in these scenarios, the bridge is a single point of failure. In distributed systems, a single point of failure are a big concern because we want to minimize downtime and provide uninterrupted service for users. So let's take this system as an example. And let's try to detect where is the single point of failures here. So I highly recommend you to stop the video and try to understand where is the single point of failure. So for your information, we have three single point of failures. The first one, we have only one load balancer server. The second, we have only one cache server. And third, we have only one database server. In the app servers, we have two. So if one goes down, the other one will continue working. So the app servers are not a single point of failure. We have only three single point of failures. And let's try to think how to solve them. But let's try to understand again how to how to understand and how actually to tackle that, like, because I knew that there is three single point of failures because I train a lot, but how can we understand and how we can detect single point of failures pretty fast? So failures are inevitable in distributed systems. They can be caused by hardware malfunctions, software bugs, power outages, network issues, or even human errors. The key is to ensure that when a failure occurs, it doesn't bring down the entire system. In system design, single point of failures can include a single server, network link, database, or any other component that lacks redundancy. And this is important thing. A common way to solve any single point of failure is to use redundancy. Like, for example, if our system has only one load balancer and it goes down, users won't be able to access your services. Similarly, if you have only one database server and it goes down, your data becomes inaccessible at all. If we have one cache, okay, the cache might not be a single point of failure, but if our cache went down, or we will increase the load on the database, which will affect the performance. So to design a resilient system, the first step is to identify a single point of failure. And let's try to give you four strategies to tackle or to tackle a single point of failure and to detect a single point of failure. The first thing it will be is to map out architecture. The first thing is to map out the architecture. We should create a detailed diagram of your system showing all components and their dependencies. Look for components that do not have any backups or redundancy. These are likely the single point of failure, and we did like that. We just map out the architecture of our system, and we found that we have three components that are lacking redundancy. Number two, we should make some analysis regarding the dependencies. So, and analyze the dependencies between different services. If a multiple services rely on a single component that doesn't have redundancy, that component is for sure a single point of failure. Number two, failure impact assessment. Number three, sorry. So let's just make this file bigger. So perform a what if analysis for each component. Ask yourself what happens if this component fails. If the system would stop functioning or experience a significant degradation, that component is a single point of failure. And lastly, which is really important thing in my opinion, which is a chaos testing. So chaos testing, also known as a chaos engineering, involve intentionally introducing failures to your systems to understand its resilience. Like tools like Chaos Monkey can be help you to identify components that would have a significant impact if they fail. So right now we know how to detect a single point of failure. We see that our system has a three single point of failures, and we right now to want to know strategies to avoid single point of failures. The first thing, I guess it will be redundancy. This is the most obvious one. So redundancy is the most common strategy to avoid any single point of failure. Is to basically is this means having like multiple components that can take over if one fails. Like redundant components can be either active or passive. For example, a standby load balancer. So instead of having one load balancer, we might have like a passive standby load balancer. Like let's give it load balancer 2 that doesn't take any request, that doesn't work that much. But when our load balancer, main load balancer fails, it will handle all the traffic through the to the app servers. The second thing also is to use load balancing. Use load balancers to distribute incoming traffic across multiple servers, ensuring no single server becomes overwhelmed. Like load balancers can also detect failed servers and reroute traffic to healthy instance, avoid a single point of failure. So a load balancers also solve the problem of single point of failure. The other thing, let's focus right now on database. The other thing is to do what we call data replication. Replicate data across multiple servers or location to ensure availability even if one server fails. This can be done using like a synchronous replication, which ensure real-time consistency, or asynchronous replication, which may introduce a slight delay, but it is more efficient. So in database, we can have like some sort of master slave database. So this could be the master database, and we can have like two slaves. Let's edit like that, and one slave, and that's this other slave. I'm trying to improve my painting thing here, and basically it will replicate all the data that here. It will replicate it here and here, and maybe the master could serve all only write request, and the slaves also could serve the read requests. Which improve the performance, also improve the scalability, also improve the availability. If so we have one server went down, the other one can take as a master and continue on write requests. And if one slave or if one slave went down, we have one master and one slave is, still. So we are pretty in a solid state regarding our availability goals. In terms of the cache, we can use like a distributed cache, so we can have multiple servers are working with each other instead of one cache server that handling our cache. So if one server, our cache server went down, we have another one, and it could be like passive or active. It depends on the requirement of our application. Also, there are some things that are quite important to think about in order to fix a single point of failure, but I guess they are not in this video in this system. No, they can be used in this video in this system as well, which is to do like geographic distribution, like distribute your services and data across multiple geographic locations. This mitigates the risks of regional failures, like use a content delivery network like CDNs for distributing content globally, and multi-region cloud deployments to ensure an outage in one region doesn't disturb the entire application. Also, we can work on graceful handling of failures. Like we can design applications to gracefully handle failures. For example, if a service that provides user recommendation fail, the application should still function, perhaps displaying a messages about limited features instead of crashing. Lastly, monitoring and alerting. Proactive monitoring helps detect failures before they lead to a major outages. Set up like a healthy check to regularly access the health of each component, and automated alerts to notify your team when something goes wrong. Also, we have self-healing systems. Like a self-healing system can automatically recover from failures, such as auto scaling to replace failed servers. So to sum it up, a single point of failure are components that can bring down the entire system if they fail. If they fail, identifying and eliminating single point of failures is crucial for building reliable and resilient systems. Strategies like adding redundancy and using load balancers, replicating data, distributing services geographically, and setting up proactive monitoring can help us to avoid single point of failures and keep your system running smoothly, and help you also to ace your system design interviews in the future. So if you found this video helpful, please like it, subscribe, and hit the notification bell so you'll never miss a video, and see you in the future.